Right. So last class, I said that I'd like to revisit exponential equations. So we're going to just do back that today, and that would fall under indices. So for the heading, you'll put indices, and after that, you'll put exponential equations with one unknown. That's the plan for today, right? And I will show you guys how logarithms come into that. Do you all remember how the logarithm function works? Just asking. Do you all remember?
Yes, sir.
So, Sheena, if I ask you 5 to what power is 19,000? I given you 1 minute to tell me what that is. I given you 1 minute. 5 to what power is 19,000? Go. And any of you all could answer as well.
14.2.
Shay, do you agree? 14.2?
Oh crap, stop typing the wrong thing. That's fine.
Wait, I didn't plug it in yet, eh? But Shade,
It's the file. It's
Shade,
6.1.
is 60 is what?
I got 6.1.
Yeah, 6.1.
Right. So I trust that everybody understands the log function. Great. You'd have to put log base 5 and you put the argument. The argument is 19,000 here, right? And I would give you a 6.121. Excellent. Serena, I hope you understand that, right? I trust and I understand that. If you don't understand it, message me on WhatsApp. Tell me you don't understand it. Right. So exponential equations. Right. So I'm going to give you all the basic formula that works for all of these questions, and then I'll show you all why the formula works. So the first thing you want to do, on either side, apply the rules for indices so that you have the same base on either side. Raised to a power. So ideally, you want to end up in this situation where you have a to the power n is equal to a to some power, right? We could call it b. Ideally, that's what you want. When you apply the rules for indices, you should end up with one term on either side that has the same base to some power. And once you have that, you could drop the base and equate powers and find for x. Once you have one base, once you have one once you have the same base on either side, to some power, you can equate the powers and solve. So as soon as you guys have this copy down, let me know and we can move on. Guys, as soon as I have this copy done, tell me, no stick.
I have
She,
it written down.
nearly finished?
So I'm
Sheena,
done.
you done? Serena, are you finished?
Yes, sir.
Yeah? Okay, I actually heard you that time. That was good. All right, so let's look at an example. Suppose we had 2 to the power x is equal to 64. Now, all of us know that we could use logs to find that, and all of us know we could just use a log function. Yeah?
Yes, sir.
If I wanted to use a log function, I'd say log base what?
2.
64, right? And that would give us the answer. Now, what you could also do is you could try to write 64 as 2 to some power. So I'm going to write back 2 to the power x. And does anybody know what would have to raise 2 to get 64? 2 to what power? Tell me, guys, 2 to what power would give you 64? Does anybody know? I could write 64.
6.
So 6. So let me ask you this. Let me ask you guys this. Is this in this form where you have the same base star power? Yeah? No?
Yes, sir.
Yeah, it's in the exact same form. And so once we have this form, we could drop the base and just equate the powers. And Shay, let's try to understand why. So Shay, what's the only difference between this and this? The bases are
One is, oh yeah, the bases are the same, but one is an unknown index and the other one is known.
exactly. And if we want to get 64, we are seeing here that you have to raise 2 to the power 6. So the answer for x would just simply be 6. Because the bases are the same, the powers have to be equal for it to be equal. You understand? So if the bases are the same, then the power would also have to be equal for the equation to be equal. Is that something that's confusing you?
Also,
Because, Shay, if I want to get 64, wouldn't x also have to be 6? So we get 2 to the power 6 is equal to 2 to the power 6? Yeah,
yes, sir.
great. So x is equal to 6. That was fairly simple. Let's do another example. Okay. All right. It's okay. Let's do this question. First things first, guys. Do we have the same base on the left-hand side and on the right-hand side? Yeah or no?
No, sir.
Shayna, what's the base on the left-hand side?
3.
On the left-hand side.
Oh, sorry, 27.
And on the right-hand side, we have 3. You're going to ask yourself, right? Is there any way I could write 27 expressed as 3 to the power? Is that possible? 3 to what power is 27? Anybody can tell me. 3 to what power is 27?
3 cubed.
Right? Now I'd put that in brackets because this represents the 27. And I was raising the 27 to the power x plus 1. And that would be equal to 3 to the power 4. So Shay, let's apply the rules for indices that we should have learned thus far. So Shay, in this scenario, we have a power to a power. So what's going to happen?
You'll be multiplying the powers by each other.
Right? So that 3 is going to be distributed across both of those terms. So tell me what to write as the power for 3.
3 to the power of 3x plus 3.
All right, and that would be equal to 3 to the power 4. Are the bases the same?
Yes, sir.
So we're trying to figure out what would x be. When I plug it back there, I will get back 4. So what value for x will give us back 4? So we could write 3x plus 3 is equal to 4 and solve from here. So what am I going to do? Walk me through this fast. 3x will be equal to
3x will equal to 4 minus 3.
right? 4 minus 3 is 1. Then I will divide both sides by 3. Yeah. And so x would be equal to.
A third.
And if I wanted to check if my answer is correct, what could I do?
Work it out in the equation.
Yeah. Are we supposed to get what?
You're supposed to get out x is equal to 1/3.
Not quite. Let me show you what I mean. By the way, your Casio calculator could do this question for you, huh? Would you like me to show you how to do it on the Casio?
Yes, sir.
Yeah? All right. So anytime you want to check if your answer is correct, you're gonna plug it back into the equation. So when we plug in a third into this equation, we're supposed to get 3 to the power 4. First of all, let's figure out what 3 to the power 4 is. 3 to the power 4 is 81, right, She? So when I plug a third into this, I'm supposed to get 81. Let's see if that's the case. So 27 to the power 1/3 plus 1. We get back 81, so the left-hand side is equal to the right-hand side. Great. Now, let me show you guys how to check if your answer is correct using the Casio again. So, you have this exact Casio?
Yes, sir.
Great. And for those of you that don't, it's more or less the same process. What you're going to do is you're going to input the equations. You're going to put 27, right? Then you're going to press x to the power. To get x, you're going to press alpha, close bracket. You should see x come up. Then you're going to press plus 1. So are you guys with me up to this point?
Yes, sir.
Shay, are you with me up to this point? Serena?
Yes, sir.
Okay. Then we're gonna press the right arrow. To get the equal sign, you're going to press alpha calc. Right? Then you're gonna press 3 to the power 4. If you don't have this, let me know now. Yeah, does anybody have this so far?
Yes, sir.
Now you're not gonna press the equal button, eh? You have to press shift calc to solve it. You're gonna see x is equal to -4. Don't worry about that. Just press equal, right? Press equal, and you should see x is equal to 0.33333. And what do we know that is as a fraction? Somebody tell me, what's 0.333 as a fraction?
1/3.
Right. Are you all getting 0.333 on the calculator?
Yes, sir.
Great. Yeah, the Casio calculator is goated. So let me give you all a question to try. All right, I'm timing you all 3 minutes. Give that a go. And if you finish that before 3 minutes, you could try this question. And if you all not sure if your answer is correct, you know how to check if it's correct. You know, you could either plug it in or you could let a Casio calculator work it out for you. Shay, did you get through?
Yes, sir, just checking it over.
Okay, bet. Sheena, did you get through?
Start checking the files.
Okay. Isaiah, did you check over? Isaiah,
Yeah,
did you check over?
yeah.
Right, the first one is correct. And the second one is correct as well. Great. Yeah, Shay and Sheena. Um, Serena. Guys, how things looking? Good, bad, grim? Tell me. All right, so let's attempt the question. I didn't get any working from you guys, so let's move on. So for question 2, what base did you decide to go with?
5.
5, okay. Is there a reason why it didn't suddenly working yet?
I was checking over question 3 and just wanted to send all one time.
Oh, okay. Wait, you finished question 3 as well.
I was doing question 3.
Oh, okay. Serena, let me see what you have here. No, Serena, you're not wrong, 25 to the power 1.5. That is 125, but how you figure that out? Tell me, Serena, how you figure that out? Because everybody would have C5. Because when I look at this, I see in 5 squared and I see in 5 cubed. I not seeing 5 to the power 1.5. All right, we gotta do some work. Oh, I see erase the 1, 2. I see erase the 1, 2. I was not gonna be like 125 to the power 3 is not. That's a big number. She. In the second line you have it seems to be
Yeah, I was supposed to erase that. It's supposed to be 5 to the power 3. Oh, 5 cubed.
right. Okay, let's do the question. So I could write 25 as 5 squared. I would put that in brackets to the power minus 2x plus 3, and that would be equal to 125. Now 125 is 5 to the power 3. I'll apply the laws of indices. So I raise our power, it's our power, so you multiply. So 2 by minus 2x is minus 4x. 2 by plus 3 is plus 6. And that would be equal to 5 to the power 3. We have the same base, so you drop the bases and you equate the powers. So we're going to say minus 4x plus 6 equal to 3. Now, the plus 6 does not belong there. We want to isolate the x term, so I'm going to move that across. I will end up with 3 minus 6. So 3 minus 6 is minus 3. And what's the last step, Shana?
Oh, you divide by minus 4 on both sides.
All right. And minus 3 divided by minus 4, negative divided by negative is a plus. So x is equal to 3 over 4. Bam. And if we wanted to check back our working, what could we do, Shana?
So that's the one thing I forget. I do the question correctly, but when I was checking over, I forget what to check over. Not the thing. So like I was like,
Okay. So Shana, you know what's the whole purpose of finding for x?
yes, so to find the power.
Not just that, to satisfy the equation. So Shana, when I put 3/4 into the equation, what am I supposed to get if it's correct? What is equal to
125.
125? So that's how you check over. So you substitute your answer into the original equation. Let's see. So that would be 25 to the power minus 2, right? Open bracket, fraction button, 3 over 4, right? Close bracket plus 3. So when I press equal, I'm supposed to get 125. Bam.
Thank you, sir. That's the only part I did forget, the checking over.
Okay, no problem. Well, in maths, if your answer is correct, well, the left-hand side is supposed to be equal to the right-hand side, always. So I think after we finish with question 3, we could do a past paper question. Yeah, I'll be real. We could. So, Shayna, before we do anything, remember you want to get the same base on either side. So before I do anything, I could write 64 as 1 over what? Tell me, Sheena, is it possible to write 64 as 4 to some power?
Four cubed.
4 cube, right? Now, I want everything to be in this form, so I shouldn't have any fractions. So I would take the 4 to the power 3 and bring it up. But if I change the position of where it is, what will happen to the sign?
It's also negative.
Right, so we'll get 4 to the power x is equal to 4 to the power negative 3. You drop the powers, and so x is just simply equal to minus 3. Bam. Now, these kind of questions is common regular maths, regular C-sec maths. Let's start doing that. Okay, and how would I check if I'm correct, Sheena?
You do four to the power of minus 3.
Bam. Am I getting the right hand side?
Yes.
Great, so we good. Nice. So let's do some tricky questions. Here what? In admats, they like to find ways to sneak in a quadratic. As much chance, like I'm telling you guys, like any chance they get, they're slapping in a quadratic. So I kind of giving you an example of so what is to come. So let me get the past paper questions. Let me start off a little easy, right? A little easy. Nothing too hard. Don't want to scare anybody. All right, so Shay, let's run through this, right? When you were looking at this, what common base do you think you should end up with? What common base?
4.
4, right? I could write 16 as 4 squared. I'll write that in brackets because that's what 16 is. Then I'll write x plus 2. And you think I should leave that as 1 over 4?
Well, you could change it to the power of like 4 to negative 1.
Right, because it's understood to be 4 to the power 1 here. And if I change the position, it'll be 4 to the power negative 1, like I said. Let's simplify now. On the left-hand side, that would turn to what? 4 to what power?
4 to the power of 2x plus 2.
Nah, correct yourself,
4x to the power of 2x plus 4, sorry.
right? And that'll be equal to 4 to the power minus 1. Nice. Same base,
Yes, sir.
drop them bases, right? And you get 2x plus 4 is equal to minus 1. So we could move across the plus 4. And if you move across the plus 4, sign is going to change to the opposite operation. So according to the negative 4. So we end up with 2x is equal to negative 1, negative 4. What's negative 1, negative 4?
Negative 5.
Right? Then we're going to divide both sides by 2. So the answer is minus 5 over 2. Easy, right? What do you think, Shay? Easy?
Yes, sir.
Yeah, that was a past paper question as well. And Shayna, remind me, if I want to check if my answer is correct, what could I do?
16 raised to the power of minus 5 over 2 plus 2.
Let's see that that'll work out. Bam. Maths is very easy. Trust me, guys. It only look hard, but it's very easy. Let me do a harder question. I think you all are ready for that. Right, so we're gonna move on to exponential equations with quadratics. True. All right. Do we have any volunteers to help me solve this question? Any volunteers? Shina.
So I prefer to you need to read by example first, and then I could think after I understand.
Here, what we're gonna do it together, right? It genuinely not that hard. It only looking hard, right? But I wouldn't say it's hard, right? So first things first, right? Shina,
Mm-hmm.
here how this is work. You're looking to see if there's the same power being repeated. So, for instance, when you look at this equation, I'm seeing 3 to the power 2x over here. Are you seeing that being repeated anywhere else? Or you seeing something close to it?
Yes, so 3 to the power of minus 2x.
Right. So let me show you how we're going to do this question. So I'm going to write back 3 to the power 2x. Then I have minus 9. And look closely at what I'm going to do. I'm going to write 3 to the power 2x. And I could write that to what power? You make a guess. What power do you think I could write 3 to the power 2x to get back 3 to the power minus 2x? Remember, if you're raising a power to a power, they multiply. So what would I have to multiply by 2x to get
Minus 1.
minus 1? Yeah. And that'll be equal to 8. Say with me so far, right?
Yes, sir.
Can you identify that we have the exact same thing over there and over there?
Yes, sir.
So at this point, you could usually say, let whatever it is be equal to y. So in this case, we have 3 to the power 2x being repeated throughout. We can call it y to make things look simpler. If we call it y, we end up with y minus 9. You continue. 9 minus 9. So anyway, you see 3 to x, you replace
Y to the
y,
power of minus 1
right? Y to the power minus 1. And,
equals 8.
and here what? We kind of know that we're going to end up with a quadratic. So we should probably move across everything to one side. So you see that? Does see that equal 8? Let's move it across one time. So did I lose you at any point?
No, sir.
Great. Now, isn't it possible for me to write y to the power minus 1 as 1 over y? Y to the power minus 1. Do you understand that that is equal to 1 over y?
Yes, sir.
Okay, so if I have 9 multiplied by y to the power minus 1, that's the same thing as 9 multiplied by 1 over y. 9 by 1 is 9, 9 over y. So, Shay, are you confused at all as to how I went from here to here?
No, sir.
Serena, tell me on WhatsApp if you're confused. Isaiah, I'm sure you understand this, but still, let's confirm with me. I will leave this to somewhere to the side. So if you're looking back at this and if I ever forget, it's there. Cool. Okay, Serena. So, Serena, I'd like you to unmute. Right? So, Serena, which part exactly confusing you? So, like, here to here confusing you? Yeah? Okay. So, Serena, let's go through back the concepts of negative powers. First things first. Let me just say I had, okay, let me just say we had 5 to the power minus 1 all over 1. What you need to understand is, if you change the position, if something was in the numerator and you place it in the denominator, then the sign for the power is going to change. So Serena, in the numerator, the power is -1. If I take it and I send it to the denominator, that's gonna turn to 1 all over 1 multiplied by 5 to the power 1. Did I confuse you there?
No, sir.
Okay, if I had 1 all over 5 to the power -1, but this time it was negative in the denominator, I would bring it up to the top and I would end up with 1 multiplied by 5 to the power 1, or over 1, which is just 5. All right? So tell me, Serena, if I had x to the power -1, what's another way I could write x to the power -1?
You could write it as 1 over x to the
Perfect.
power.
Yes, which is just 1 over x, right? So you understand it now?
Yeah.
So in this particular question, we had 9y. I probably shouldn't erase that. Yeah, so Serena, in the question, we had 9 multiplied by y to the power -1. So what would y to the power -1 be?
It would be 1 over y.
And if we have 9 multiplied by 1 over y, wouldn't that be 9 over y?
Yes.
Yeah, so confused, I understand now.
I understand now.
Nice. So here, stay unmuted and let's continue, right? So I'll write back the -8 and I'll put it equal to 0. Now, Serena, do we like working with fractions?
No.
No. So if I have divided by y, what can I multiply by to cancel off with that y?
Y.
Why? That's not rocket science, right? Anytime you want to get rid of something in the denominator, you just multiply by that same number or same term. So I'm going to multiply by y throughout. Remember, if you do something in one place, you have to do it everywhere. So tell me, Serena, if I'm multiplying everything by y, what's y by y,
Y squared.
right? We're going to end up with 9 over y multiplied by y. We're going to have one of those two y's,
The two y's would cancel out, so you just have -9
right? And what's -8 by y?
-8y.
Equal to 0. Perfect. So you're with me so far? I didn't lose you. Shay and Shayna, did I lose you guys at all?
No, sir.
No, sir.
You guys good so far?
Yes.
Okay, well, Serena, let's continue. So we have y squared minus 9 minus 8y is equal to 0. Now, and I know that you are accustomed seeing x, but it's the same thing when you have y. So ultimately, we have something that's in the form ax squared plus bx plus c. Serena, tell me if you're having a hard time seeing what I'm talking about.
No, I could see it.
You could see it, all right? So if I want to put this in this exact form, I would need to write y squared first. What should I write after y squared?
-8y.
Yeah, minus 9. Okay, so now we have to see if it's factorizable. So to get y squared back, I would say what by what,
Y by y.
right? And I'm going to ask you, so I'm going to ask you to look at the last term. The last term is -9. How could you multiply to get -9, but add to get -8?
+9 and -1.
Okay, but if you combine those two terms by adding them, what's +9 plus -1? Would that give you -8?
Oh no.
Nah, watch. If you have +9 plus -1, you're going to get 8. We want to get -8. So where do you think we should put in negative number by?
The 9.
Exactly. It makes sense. If you want to get a negative number in the middle, chances are you should put in negative number by the bigger number, and
Yeah.
right? So it should really be -9 by +1. Yeah.
Yes, sir.
So it doesn't matter where you put the -9 or the +1, right? It'll still be correct. So y -9, y +1. So you're with me so far?
Yes, sir.
Great. So now we're gonna have two different answers. Y minus 9 is equal to 0, and y plus 1 is equal to?
0.
Great. To find for y here, you're going to move across the minus 9, and you're gonna end up with y is equal to?
0 plus 9.
Right, what is 0 plus 9?
9.
Nice. Over here, we're gonna end up with y is equal to?
-1.
Right. Now we are not done. You need to remember what, so Serena, you need to remember what we had decided y was equal to. What did we say y was? Y was equal to what?
3 to the power of 2x.
Right. Ladies, anybody confused? Remember at the start, we had said that 3 to the power 2x would be equal to y.
Yes, sir.
Are you confused or are you okay so far?
Okay, so far.
Okay, Shay, are you okay so far? Shay, tell me if you're confused. Check
No,
everything.
sir.
Okay, you're good. Nice. And Isaiah, if anything's confusing, you just send me a message and I'll re-explain it. So when you reach at this point, you have to say, you have to recall what y was. So recall that y was equal to 3 to the power 2x. Serena, do you think both of these solutions are going to be valid solutions?
Um, I'm not sure.
Yeah, sure. Okay. That's all right. So we have y is equal to 3 to the power 2x. So the first one is going to be 3 to the power 2x is equal 9. Yeah, Serena, did I lose you over here?
No, sir.
So you understand that I'm just continuing. I'm just replacing the y here with 3 to the power 2x. That's it.
Yeah.
Now, let's apply the same rules you have learned thus far. We want to get the same base. We already have 3 over here. Is there any way I could write 9 as 3 to some power?
You could write it as 3 to the power of 2.
Do we have the same base on the other side?
Yes.
Yes, we could drop the base and equate the powers. So we will say 2x is equal to 2. Nice. Then we're going to divide both sides by,
2.
right? So x is equal to,
1.
how do you find that was?
Actually, pretty easy.
I know, right? It only look complicated. It only look complicated. And if you look at it working by itself, you might say, oh gosh. But if you do it, it's not that hard. It's really not. Now let me explain to you why the second solution is invalid. Ladies, remind me, can we find log of a negative number, or is there any power that would give us a negative number?
No, sir.
No. Serena, can you think of any power that would give you a negative number?
No, sir.
Wait, tell me raise back the volume. Yes, Serena, is there any power known to mankind that would give you a negative answer?
No, sir.
Nah, right? So this will be invalid because there's no power you could raise 3, 2 to get -1. And well, Serena, if you're thinking, well, maybe I could raise 3 to some negative power. Maybe that might give my negative answer. No. Let me show you what I mean. We just looked at this rule over here, and I told you if we have a negative power, we can make it positive by shifting its position. So if we have 3 to the power -1, do you really think that would give us -3? Tell me, Serena, that wouldn't give us -3, right? That would actually give me what over what?
It would give you 1 over 3.
So there's no power that would give you a negative number, right? There's also no power that would give you 0. Let me explain why. Serena, you remember what any number to the power 0 is?
It's 1.
1. So here what? There's no power. I'll make a note of it here as well. There are no powers there are no powers, right? There are no powers powerful enough to give us 0 or a negative number. Serena, do you know why? You know why conceptually that powers can't give you negative numbers? Do you know why?
I think you explained it, but I don't remember.
It's okay. When you have powers, so for instance, right? If I had 3 to the power 2, what does that mean?
It means 3 multiplied by itself.
Okay, if I had negative 3 squared, what would that mean?
It would mean negative 3 multiplied by itself.
Exactly. So, is there any condition where you get a negative answer?
No.
No, right? There isn't any because a positive by a positive is a positive, and a negative by a negative is a
Positive.
exactly. Right? I believe there's one exception, like for odd powers. Let me just check something real quick. So let's just say, for instance, we wanted to figure out minus 3 to what power would be so this is the only one exception. Shay, let's run through this one exception, right? Before you unmute, let me lower my volume. Yeah, so Shay, you might be thinking here, well, um, how could a power give me a negative number? But Shay, I want you to realize something. In this example here, I'm saying it's valid because look at the number we are raising to our power. You see now?
Yes, sir.
The number we're raising to our power there is what?
-3.
Yeah, negative 3. So for any odd times I'm multiplying the number, I'll always end up with a negative number. For any even number of times I'm multiplying minus 3 by itself, I'll get a positive number. Did that just confuse you?
No, sir.
No? Yeah, so
Wait, just explain back one more time.
okay, you understand that an even number is a number divisible by 2.
Yes, sir.
So let me give you an example. If I multiply minus 3 by itself 2 times, that's an example of an even number of times. Okay? If I said minus 3 by minus 3 by minus 3 by minus 3, I multiplied minus 3 by itself 4 times. So that again is an example of an even number of times. Yeah?
Yes, sir.
If it's an even product, the final answer will be positive. Why? Because minus by minus is plus. Yeah. Minus by minus is plus. Minus by minus is plus. Final answer is positive. So in this scenario, if you have an even power, you'll get a positive answer. You with me so far?
Yes, sir.
If it's a odd power, like minus 3 but minus 3 to the power 1, that's just minus 3, negative number. If you had minus 3 by minus 3 by minus 3, and you'd end up with a negative number.
Yes, sir.
Yeah, so this is the one situation where it could get a negative answer, but by itself, could a positive base ever give you a negative number?
No, sir.
Nah. And Serena, I want to explain that back to you again, right? So Serena, unmute again.
Yes, sir.
Yeah, so Serena, I'm seeing that for a regular positive base, that can't give us a negative number because Serena, doesn't powers mean what by what is what? Think about it. If I have 3 squared, doesn't that mean 3 by 3?
Yes, sir.
If I have 3 cubed, doesn't that mean 3 by 3 by 3? Come on, Serena, if you're with me. Serena, are you talking?
Yes, sir.
Okay, I kind of hearing you. So, Serena, if a positive by a positive is always a positive, then is there any power I could raise 3 by to get a negative number?
No, sir.
No, that just don't make sense. So, if you have a positive base, there's no power that would give you a negative number. If you have a negative base, well, yeah, it's possible, right? So, anytime you encounter a situation like this, you just put invalid. And you can put a reason why, because that would look well. That would look really good. If you could understand, if you show them why, that would look good as well. So do that as well. So I'll give you some time to copy down this example, and I will give you all a question to try on your own. So Shay, would you have had done questions like this in school as yet?
No, not really. More the basics.
And you're handling this so well.
Uh,
Like for me, it sounds like you do it already.
not really. Just like the basic rules and stuff I remember, but
Okay, okay. Well, I'll give you all a question just now, and I'll see how well you understand it. Shayna, you too, like I found out you're really getting this thing fast. So big up on yourself. So as soon as you have everything on your screen copied down, you'll let me know. If is it that you'll aren't seeing everything clearly? Let me know if you guys seen everything clearly. Is there anything you
So
all
we
can't
seen
make
everything.
out? Shay, is there anything you're struggling to make out?
no, sir. I understand everything for now.
Shina, is there anything that's hard to make out?
No, sir.
No? Okay. And Isaiah, you'll let me know if you're okay with everything so far.
Yeah.
Yeah? Okay, cool. Yeah, so as soon as you have that copy down, tell me, right? Okay, Serena, you have it written down. Cool. Shay and Sheena, uh, how things looking?
I'm done too.
You're done? Shay, are you done?
Yes, sir.
Okay, let's move on. So this might be a bit crazy, but I've given you all 5 minutes to at least try something so I can see what you come up with. So I will give you all some hints and some advice. So Shay, you see how we have 2 to the power 2x plus 1?
Yes, sir.
Maybe you should try to break that up. Maybe you should try to break it up using your rules of indices. Wait, sir. So let me just elaborate what I'm saying. So everybody knows that so Shay, if you have powers that have been added, most likely you would have had a situation where the bases were the same and you were multiplying the bases. Yeah?
Yes, sir.
So imagine you had 5 to the power 3 plus 2. If you were to undo that, that would be 5 to the power 3 multiplied by
5 to the power of 2.
exactly. Additionally, you want to end up in a situation like last time where you could have make a substitution. In this case, we could have, there was some way for us to write 3 to the power 2x and 3 to the power 2x 2 times. Now, I'm not saying that will be the exact case over here, but try to find some scenario where that's possible. My hint would be 2 to the power x. See if you can get 2 to the power x in 2 places so you can make a substitution. So these are my hints to you guys. I'm giving you all 5 minutes. Take a go at it. Yeah, guys, tell me how we going. Guys?
So I'm just a little bit lost on what to
So
do.
it's going somewhere.
Shayna says it's going somewhere. Shay, you're a little lost.
A little lost on what to do with the 5 with the brackets to the power x.
Truth be told, you really can't do anything, you know. You really can't
Oh,
do anything. You really can't do anything with that. If you say 10, no, you can't do that.
yeah.
So, Shay, my advice was in the previous question, we found some way to write 3 to the power 2x twice. In this question, try to isolate 2 to the power x so you can make a y substitution. So, you see that 2 to the power x there? At some point, you're going to call it y, and you're going to end up with 5y. The hardest part is to figure out how you're going to deal with 2 to the power 2x plus 1. And to deal with that, you have to undo it using the indices, the rules for indices. So again, my example was 5 to the power 3 plus 2. What would that be? Well, that could be 5 to the power 3 by 5 to the power 2. So if you don't fully understand, that's okay. We learn in, I'll do the questions with you. Okay, time is up. So Shay, let's attack this question. Right. So Shay, let's go. The first thing we have is 2 to the power 2x plus 1. And now Shay, you notice that we have a sum of numbers there, right? A sum of numbers. There's a sum. Yeah?
Yes, sir.
And if there's a sum, again, if you had 5 to the power 3 plus 2, that would have meant 5 to the power 3 by 5 to the power 2. So what do you think 2 to the power 2x plus 1 could be written as?
2 to the power 2x multiplied by 2 to the power 1
Excellent.
or 2.
Right? 2 to the power 2x multiplied by 2 to the power 1. Excellent. Then we're going to write 5. Now you can't say 10 to the power x. You can't do that. Let me explain why. Shay, if you had 5 to the power 2 squared, wouldn't you have to work 2 squared first, then multiply by the 5?
Yes, sir.
Yeah, you can't say 5 by 2 is 10 until 10 squared. No. You have to, if something's raised to a power, unless you simplify that, you can't do anything to it. So we can't do anything to that 2 to the power x. I'm just going to write it back. So I'm going to write back 2 to the power x minus 3 is equal to 0. Now, I was telling you that you want to look out for 2 to the power x. That's what you want to do. So, Shay, I have 2 to the power 2x. If I just want 2 to the power x on the inside, I could write 2 to the power x raised to what power? So if I want to write 2 to the power x there in that bracket, and I want to get back 2 to the power 2x, I'd have to raise this to what power to get back
2.
2x? 2n's, nice. And like you said, 2 to the power 1 is just 2n's,
Yes, sir.
right? 5. And again, I can't do anything without 2 to the power x. I can't do anything without. So this is the situation we have so far. Did I confuse you in at all? At all?
No, sir.
No? Okay. Are you seeing the 2 to the power x in two places?
Yes, sir.
So just like the last question, you figure out what I'm gonna write. I would say what? Let what?
Let 2x equal y.
Yeah. And if I do that, what should the next line look like?
Y squared multiplied by 2 plus 5 y minus 3 equals 0.
Ah, does that look like a quadratic?
Yes, sir.
So what is y squared by 2? Wouldn't that just be 2y squared? 2y squared plus 5y minus 3 is equal to 0. Now, I want to show you guys the AC method. So, so far, anytime we had a quadratic, it was very easy to factorize. And that's because the coefficient of the squared term was always 1. Let me just elaborate what I mean there. What's the coefficient of y squared over here?
1.
1. And so it was very easy to factorize. Very, very easy. You're just looking at the last term. How could you multiply to get that and add to get the middle term? Simple. But it's a bit more complex when the coefficient of the squared term is not 1. So let me show you all how we can handle that instantly. So how this will work, right, Shay, is that you're going to look at the first term and you're going to look at the last term, yeah? You're going to multiply those two terms by each other. So this is my version of the AC method, right? So it's called the AC method because you're multiplying the first term by the last term. So the A term by the C term. So, if you multiply 2 by minus 3, what will you get?
Negative 6.
Negative 6. Now, again, it come like the exact same scenario as last time. How could you add to get minus 6, but multiply to get plus 5? Tell me, Shay, what can you multiply to get minus 6, but add to get plus 5? Shay, is that confusing you? So think of two numbers I could multiply to give you minus 6, right? But add to give you plus 5.
Add negative 1 and 6.
Right? And from here, we just factorize it like how we would normally. So there's one difference. So in all the previous questions, the coefficient was 1, so it'll just be x by x or y by y. In this rounds, we have 2y squared, right? 2y squared. So how would I get 2y squared?
One would have to be 2y, the next one would have to be y.
Right. Now we need to figure out where we're going to put minus 1 and 6. We need to figure out where we are going to put that. Now, if I put the minus 1 over here and the plus 6 over here, if you do the multiplication quickly, you'll see that, yeah, you're getting back 2y squared, but this 2y would multiply by the 6, and you'll get what? What's 2y by 6?
12y.
Yeah, and that kind of far from plus 5.
Yes, sir.
So maybe we should switch the minus 1 and the 6. So I could write plus 6 over here and minus 1 over here. Now, that's gonna be 2y squared minus 2y, but that's still not gonna give us 5. I wonder if this was the question with the error, boy. There was one C-side question with an error. Let me check. So anytime you run into problems with factorization, input the quadratic into your calculator to make sure it's factorizable, right? So equation function, polynomial, degree of 2. We have a coefficient of 2 for the for the x squared term. For the x term is 5, and for the c term is minus 3. Wait. Okay, so this is factorizable. So there must be another approach, right? So this is not going to work out. You see why it's not going to work out? 2y by y is 2y squared, right? 2y by minus 1 is minus 2y. plus 6y, that wouldn't work out, right? So we would have to figure out another way to get minus 6. So Shay, what's another way we can get minus 6? Do you know another way to get minus 6? Forget about it adding to your plus 5. We'll see what happens next. Give me another way to get minus 6. Tell me, Shay, what's another way to get minus 6?
The 3 by 2 is like,
2 by negative 3?
yeah.
Let's see if that will work. Let's see. Let's try the plus 2 over here, and let me write the minus 3 over here. If you were to expand this out, you get 2y squared, right? 2y by minus 3, that's minus 6y. Minus 6y plus 2y. Now that wouldn't work out. That wouldn't give us the result we're looking for. So we should do a switcheroo. So we should put the minus 3 over here and the plus 2 over here. Let's see if this works. So Shay, 2y by 2 is? That'll be 4, and then, nah, that wouldn't work out either. That's interesting. Wait, give me a second. Let me just speed run the question in my head. 2y, y, 3, okay, no. So squared. Right. Right, this is how to work out. So 2y by y is 2y squared, right? 2y plus 3 is 6y. And yeah, that would work out. Just confirm that working out, Shay. Just confirm if that working out. Make sure that we get plus 5.
Yes,
If
it
that-
works out.
Okay. That's why I kind of abstain from the AC method. It says to multiply A by C, but it always work out like that. When we're doing quadratics and maths, I'll go over the AC method more. But for now, I prefer to stick to this. This is like the easiest approach. So shape. This is the approach I just take. Right? So let me show you how I did it. So shape, it's more or less the same process I would have showed you from the start. To get back 2y squared, it'll be 2y by y. Yeah? And how could you what are two numbers you can multiply to get minus 3? I mean, you only have
1
two.
and minus 3.
1 and minus 3. Now, the only tricky part is you'll have to figure out where you're going to put the 1 and where you're going to put the minus 3. Now, pay attention to something, Shay. You want to get a positive number in the middle. So do you think you should put the negative number by the bigger number? If you want to get a positive number in the middle, do you think you should put the negative number by the 3?
No, sir.
Nah. So we're going to get a positive number. So you should probably put it by the minus 1. By the 1. Okay, and the next thing, in your head, try to run through these scenarios. If I want to get plus 5, shouldn't I put that 3 so that I would multiply by the 2 to get 6, and then the minus 1 will give me 5?
Yes, sir.
So where would I put the 3 to multiply by the 2? Would I put it over here, or would I put it over here?
You put the negative 1 by the 2.
Right. And I'll put the plus 3 over here. Because if the 3 is over here, and you could visualize that it would multiply by the 3, the 2y would multiply by the 3 to give me 6y, and then minus 1 by y will be minus 1y. So 6y minus 1y is 5y. So yeah, that's correct. Serena, would you like me to go over this method? I will show you all the AC method the next session when we're doing quadratics and regular maths. But I really like the AC method. This method is just quoted. It's work every single time. Serena, would you like me to re-explain this? How to factorize a quadratic whose coefficient for x squared is more than 1? Let me know, Serena. Let me just raise my volume because I can't hear you if you're talking. Yeah, Serena, try talking now.
understand.
Okay, so Serena, let's run through that one more time, right? Just to make sure. So Serena, the first term there is 2y squared. And take it back 2y squared, I'd have to say 2y by y.
Yeah.
And take it minus 3. Wouldn't I just have to multiply minus 1 by 3?
Yeah.
Now, I want to get plus 5 in the middle. If I want to get plus 5 in the middle, do you think it makes sense to put a negative by the bigger number?
Yes.
Okay, then you do fully understand. Serena, if I want to get a positive number, should I put the negative by the 3 or by the 1? Where should I put the negative number? By the 3 or by the 1? Okay, Serena, let me give you some examples of what we're talking about, right? Imagine you had 7 and you had 5. So we start off with plus 7, right? Plus 7 minus 5. What will you get there? Tell me, Serena, what's plus 7 minus 5?
Positive 2.
Right? Positive 2. If I put the negative by the bigger number, which is the 7, what will I get?
You get negative 2.
So if I want to get positive 5, which is a positive number, should I put the negative by the smaller factor or the bigger factor?
Oh, the bigger factor. Sorry, I
No.
didn't understand what you.
Wait, not quite. I just asked you, if I want to get a positive number, should I put the negative by the smaller factor or the bigger factor?
To get a positive number, you put the negative by the smaller number.
Exactly, the smaller number. Because I want the positive number to dominate. And so, if you expand this, it should work out back. Watch, 2y by y is 2y squared. What is 2y by 3?
6y.
Positive 6y, and minus 1 by y is minus y. What is 6y minus y? 6y minus y.
Positive 5y.
Yeah. So, Serena, let's actually finish this. You're going to have 2y minus 1 is equal to 0. And you're going to have a y plus 3 equal to 0. Now, this first solution is going to be 2y is equal to 1. Then you will do what on both sides?
Divide both sides by 2.
Right? If I do that, I'll end up with y is equal to a half. Yeah? Now, if I move across the plus 3 here, I will end up with y is equal to what?
Negative 3.
Now, we can't forget what we said y was. Initially, we said y was what?
Y was 2 to the power of x.
Right? So recall that y was equal to 2 to the power x. Which one of these solutions is invalid already?
Y equals negative 3.
Right, because is there a power that can give you a negative number?
No.
No. Shay, do you understand why y is equal to minus 3 is invalid? Or nah? Shay?
Yes, sir, listen.
So why would the solution be invalid?
Because no number could equal to a negative number in terms of powers.
Yeah, that's correct. So this is invalid. All right, so you'll end up with 2 to the power x is equal to a half. Now I could write a half as 2 to what power? A half is the same thing as 2 to what power?
Negative 1.
Anybody? A half is the same thing as 2 to what power? Shina.
Negative 1.
Okay, yeah, negative 1. So we have the same base here. So now we can equate the powers. So x would be equal to what? What's the answer, guys? X would be equal to?
-1.
Yeah. Right. Now, could somebody tell me how I would prove if my answer is correct? Could somebody tell me how to check if my answer is correct? Sheena, you're the person for this.
Oh, okay. I guess you could substitute x into -1 wherever I see x in the initial equation.
Yes, that's correct. So let's see if that will work out. And when we do that, what are we supposed to get? If you look at the original equation, it's equal to what?
0.
So we're supposed to get 0. So let's see if that'll work out. So starting off with 2 to the power 2, right? Open bracket -1, because x is -1. I'm replacing x with -1, right? Plus 1 plus 5, open bracket 2 to the power -1, close bracket -3. So when I press equal, what am I supposed to end up with, Shane? As soon as I press equal, what am I going to end up with? Uh,
0, sir.
0. Let me see. Bam. So is my answer correct?
Yes, sir.
Yeah, we're good. So copy this down. I'll give you all one more question like this, and then we'll move on to something else. Don't worry, when we are finished with this topic, we'll do a bunch of past papers to lock in. So when school starts back, we're gonna do past papers on this. So I will see how much of you guys remembered as a plan. We will see how much you guys remember. So as soon as you all have the question copy down, let me know. All right. Does everybody have his copy down or still copying down?
So I have it.
You have it? Okay, great. Shay, what about you? Do you have it?
Yes, sir.
All right. Serena, Isaiah, you let me know. Isaiah, let me check what you have here. Okay, yeah, you figured it out. Nice. So, time for a question. So I'm expecting you guys to get this question correct this time around. Shay, think you get it correct?
I don't know about that, sir.
You don't know about that? I promise it's very similar to the previous example. Shina, do you think you'll be getting the question correct?
I think I'll try to get it correct.
But you're not 100% sure.
So I know what to do is it's just that I didn't see question yet. So I know when I see all
No,
that.
no, you have it, you have it. All right, so try this question. Giving you all 5 minutes. It. Shina, do you think you have a handle as to what to do?
Yes, sir.
Great. Shay, what about you?
Yes, sir.
Okay, cool. Serena, you let me know in the chat below on WhatsApp. Isaiah, let me know as well.
What's that? I didn't answer the question.
You finish your question?
No.
Okay. All right, shit, are we nearly at an answer? Shay?
I'm just substituting back the y into the equation. Well, yeah.
You mean X?
Yeah.
Okay. Sheena, where are we? Sheena,
I'm factorizing.
factorizer.
Mm.
All right, so the time is up. So I didn't get an answer from. I want to wait till I get an answer because I'm waiting on an answer from Sheena, Shay, and Serena. Guys, I'm waiting. I at least want to see something. Guys, wait. Shay told me that you were checking back your answer. Did it work out or it didn't work out?
I just said what I have so far.
Okay. And I'm waiting on a picture from Sheena. Sheena, I'm waiting.
So as soon as I have so far also, I did not reach recall.
You see that again?
I said I could send what I have so far, I did reach the recall y equals the yeah.
Tell me what you have so far. Were you trying it the whole time?
Yes, sir.
Okay, tell me what you have so far. Sheena, let's see what you have. Okay, great. So let's begin, right? So Sheena, let's do the question together. So Sheena, we're gonna start off with undoing what we have. So we have 3 to the power 2x plus 1. Now, notice here there is a plus sign in the power, which would have meant that you multiply the same bases. So that would be 3 to the power 2x multiplied by,
3 to the power of 1.
right, minus 5 by 3 to the power x minus 2 is equal to 0. Now I could write 3 to the power 2x as 3 to the power x raised to what power?
2.
Right? By 3 minus 5. Do you notice something in common throughout?
Yes, so 3x.
Right, so we're gonna say let 3 to the power x be equal to y. Now, if we say that, then you're gonna end up with y squared by 3, right? Minus 5y minus 2 is equal to 0. So let me just check where you did so far. Yeah, yeah, have that. So did everybody end up at this stage? Tell me, did everybody end up at this point? So 3y squared minus 5y minus 2. All right, so just indicate on WhatsApp or unmute. Okay, did you reach this point? Let me see, 3y squared minus 5. Yeah, sure, you reached this point. Cool. Serena, yeah, you reached that point as well. Nice. So Shina, let's factorize this. So to get back 3y squared, I have to multiply what by what?
I did 3y by y.
Right? And to get back minus 2, how could I multiply to get back minus 2?
Positive 1 and minus 2.
Right, where should I put the negative 2?
By the y.
Right, because if I place it over here, wouldn't the 3 multiply by the negative 2?
Yes, sir.
Yeah, and that would give us 6, that would give us negative 6y, and then the 1 would multiply by the y, so that'll be negative 6y plus 1y, which will give us back the negative 5y. So now we have 3y plus 1 is equal to 0, and we have y minus 2 is equal to 0. Now, what should I do next here? Tell me.
Well, you can move it over, so the 3y will equal minus 1, and then y will equal minus 1 2.
Is that solution valid?
No, sir. Invalid.
Let me
So
just,
the next one would be y equals 2.
right? So, Serena, you said that the minus outside was invalid. That's correct. This is invalid. Nice. She, did you say that it was invalid? Nah, she didn't say it was invalid. She, you see any problems?
Yes, sir.
When you move across plus 1, what that will be equal to?
-1.
Yeah, I'm not seeing any working, so I gotta be careful about that. Another thing, I'm not seeing the equal to 0 over here. Yeah, I'm not seeing the equal to 0 in this line. So two things, right? Two things. So, she, let me continue, right? She now get a break. She, I have y minus 2 is equal to 0. So if I move across minus 2, that would be equal to what?
Y equals to 2.
And what did I say y was?
Y was 3 to the power of x.
So we're gonna end up with 3 to the power x is equal to 2. Ah, now this is not like all the other cases, is it? Tell me, Shay, what do you think? Is this like the other cases where we could write everything to the same base?
No, sir.
Now, so what do you think we're gonna use for this? I'm asking you 3 to what power is 2? What do you think you're gonna use for this? What function?
The log function.
Yeah. Shayna, did you know that I had to use the log function?
Well, I probably would have recognized, but I did not reach there if you're watching.
I see that. I see that. Yeah, yeah. But Shayna, would you have had known that y was equal to negative 1, say that would have been an invalid solution? Tell me, Sheena.
If I would have known, yes.
Yeah. Anytime you get a negative answer, that means it's invalid, right?
Yes, sir.
So the only valid solution is 3x, 3 to the power x is equal to 2. Now, Sheena, do you know off the top of your head what power you'd have to raise 3 by to get 2? Is this like the other questions where I could write 2 as a power of 3? Or is it different?
I would say different.
Yeah, definitely different, right? Because in the last questions, take for instance, we had 1 over 2. 1 over 2, that's 2 to the power minus 1. Very easy. Similarly, watch, we had 3 to the power 2x is equal to 9. I can write 9 as 3 squared. So Shina, if we can't do that, then we have to use the log function. Remember, we did the log function. And if I use the log function, x would be equal to what? Log what?
Three,
Log base 3 what?
2.
Yeah. So let me know what you guys are getting for that.
I got 0.63.
Right? And they wanted the answer to 3 decimal places. So that'll be 0.63 what?
1.
Yeah. So Shay, you see how logs coming into play with us?
Yes, sir.
Yeah, because not every time you'd be able to figure out what power you'd have to raise a number to get it. Not all the time the examples are standard. So you'd need to use log sometimes. And if you wanted to check if your answer is correct, here what I'm going to do. I'm going to store this answer and I'm going to plug the exact answer back into the equation. Gills, do you know how to store an answer in the Casio calculator? Serena, if you're lost, tell me. Just send a message on WhatsApp to verify that you understand. Serena, do that for me. Just send me a message so I can know where you are at. Shayna, Shay, Serena, do you all know how to store an answer in the Casio calculator? Based on the silence, I'm not sure what to think. Shay, leave him stranded. Do you know how to store a value in the Casio calculator?
So I kind of forgot, but I know it had something to do with the store and then the A and then all of that.
Yeah, how to do that. All right, Shay, do you remember how to do it?
I just remember the alphabet part.
Oh, okay. Well, I'm sure that was to do it, right? Now, some of your calculators might be a bit different, but it's more or less the same process. In my model, I have store right here. Some of you guys will have to press Shift RCL. Notice in the calculator that you might have above the RCL, you see a yellow SCO. And because it's yellow, you'd have to press the Shift button, which is the yellow button, to get RCL. To get store. Let me say that one more time. So if you want to store it and your calculator is not like mine, you're going to have to press Shift RCL to get the store function. So who here has to press Shift RCL to get store? Shayna, do you have to press Shift RCL to get store?
No, sir.
Yeah or no?
No, sir. I have the calculator on the screen.
Or you have the exact one?
Yes, sir.
Okay, well, Serena, yeah, we're on the same page here. Isaiah, and you remember how to store a value in a calculator?
Yeah.
Great. So Serena, you'll follow with me. Ladies, you can look on the screen. All right, so Shay and Shayna. I'm going to press STO. Then you're going to press either A, B, C, D, E, or F. I'm going to store it under A, right? You should see answer, arrow, A. Is everybody seeing that?
Yes, sir.
Shay, yeah? Or no?
Yes, sir.
Okay, Serena, what you will have to do is you're going to do the same thing. You're just going to press Shift RCL, and then A, B, C, D, E, O, F. So Serena, let me know if you get the answer ROA when you press Shift, RCL, and one of the buttons on top. Yeah? Okay, cool. Then you're gonna press equal to lock it in, right? Then you're gonna clear the screen. To recall your answer, you'll have to press Shift, STO, and the button in which you stored your value under, you press it back again. So I stored my value under A, so I pressed A, right? Then press equal, and it should be the value that you stored. So are you getting back to 0.63?
Yes, sir.
Sheena, are you getting back to 0.63?
Yes.
Serena, are you getting it back? Nice. So if you all got it back, here what I'll do for now. I want a little plug it into the I want a little plug that into this expression in the calculator and send my screenshot. So this is what I want to do. 3 to the power 2, right? Then you're gonna recall the value. So, right? And input it into the expression. So you should have exactly what I have. So you should have 3 to the power 2a plus 1, right? Then I press the button to the right, minus 5, open bracket, 3 to the power, and then you're going to press Shift, recall, A, right? Close bracket, minus 2. So I want everybody to have this in their calculator, right? And I want you to press equal, and you should get 0. This is what I want you guys to take a picture of. Take a picture and send this to me. I want to make sure that everybody's getting 0. Take a picture of the calculator so I can see that again 0. Yes, I'm waiting for a picture, right? So everybody send me a picture showing that you're getting 0 on the screen. Shay, are you having a hard time inputting it into the calculator?
I cleared the I don't know how, but I cleared the things I don't have A anymore. So I have to thing.
Oh, do it back fast then. Fast. Speed, right? So Isaiah, um, I didn't teach them a change of base formula just yet because everybody here has a Casio, number 1 and number 2. They understand how the log functions work. So I just showing them that for now. When we specifically go through logs, I'll show them how to do that by applying logs on both sides and making X the subject of the formula. I'll show them that. But for now, this is the easiest thing, and it'll get them the answer. All right, so Shay, I'll wait on you, right? Yeah. Let me see. Okay, great. We're not again. So does everybody have the working that's on the screen? Let me know. Did anybody copy this one already, or you also copying this on? Because I know we was plugging it in into the calculator.
I have a copy down.
Okay, nice. Sheena, you have it copied down.
Yes.
And what about you, Serena? Isaiah, I know you have it.
I have it too.
Serena, you let me know if you have everything copied down. Okay, great. So before we finish class today, I just want to let you guys know that we are done with indices, right? This is more or less all the questions that's come with indices. The other questions would be a combination of logs and indices. Right. Okay. So there's something I wanted to touch on. Does everybody understand how to convert from log form to index form? We would have looked at this last class. Does everybody remember how to convert from index form to log form?
Yes, sir.
Yeah? Okay, well, let me do a question then. I was supposed to do a hard question on this, but I forgot. So we're gonna do that. We're gonna do two hard questions before we leave class today. So you all will know how to at least attempt it. So let me show you what I mean. So see, for instance, we had this question, right? And you could copy this under converting between log form and index form. Okay. Right. So Shay, do you know how to solve question one? Or would you immediately think it's an invalid question?
Um, I'd say invalid.
No, it's not invalid. Shay, understand the difference, right? I tell you guys that you can't find log of a negative number. This is not the same thing, right, Shay? Are you seeing a negative number inside here?
Yes, sir.
No, the log function gives you a power. And Shay, and powers could be negative, like -4, -2, and powers could be negative.
Yes, sir.
Yeah, so there's nothing wrong with this. So -4 is the power. So in other words, Shay, I I'm asking you, if 2 was the base, so here what, we're gonna convert that to index form. So if 2 was the base, right? If 2 was the base and -4 is the power, what would the number have been? What would the argument have been? Tell me, Shay. So if 2 is the base and -4 is the power, then x will be the argument. Could I find for x easily like this?
Yes, sir.
Yeah? X is 2 to the power -4. What is 2 to the power -4 equal to? 2 to the power -4 is the same thing as 1 over 2 to the power 4.
1/16.
Right. So, Shay, understand what they were trying to ask you. They were saying, and it will make sense now. So if you have log base 2 of 1/16, what would you have to raise 2 by to get 1 over 16? It makes sense now, right, Shay? Because to get 1 over 16, wouldn't you have to raise 2 to the power minus 4?
Oh, yes, sir.
Yes, I guess so, which means you're not fully confident in it. So remember, Shay, the log function tells you the power, you have to raise a number 2 to get the desired result. If I were to write it out over here, so log base 2, 1 over 16. So tell me, Shay, this is asking you, okay, you have base 2, right? What would you have to raise 2 by to get 1 over 16? That's what it's
Negative
asking
4.
you. Negative 4. So do you understand why 1 over 16 is the answer? Because you'd have to raise 2 to the power minus 4 to get 1 over 16. Or you still
Yes,
feel
sir.
a little confused about that?
No, sir.
No? Okay. Sheena, this might be a little
Yes, sir.
confusing. Tell me if it's confusing you bad.
No, I understand.
Okay, cool. So you understand that we just went from log form to index form. So it was the base to the power equal the argument. That's all we did. Right? Remember, this is the base, this is the argument, and this is the power. We're just switching between log form to index form. That's it. And when we do that, sometimes it's easy to solve the question. So let me give you guys one question to do, and that'll be it for today. Right? So log base x plus 1, 49 is equal to 2. So my advice would be convert this to index form and then go ahead and solve. That's my advice. So remember, if you need to look back at your notes, sure. This is how you go from index form to log form. So try question 2 and send me something. So Shay, all you're doing is going from that log form to the index form. Remember, the index form is the base to the power, and that will be equal to the argument. So reader, if anything is confusing you, tell me. All right, so Shayna, on a scale to 1 to 10, how confused are you, if at all?
So I want to check something before I answer that question. I want to check my answer.
Okay. Shay, what about you? On a scale to 1 to 10, how confused are you?
I'm not that confused, but just the x plus 1 is kind of throwing me off a little bit.
They'll like confuse you. Think of it as a whole term. So just whatever you do, make sure you put it in brackets. Make sure you put the x plus 1 in brackets. So Shay, understand that in a log form, it's always log of the base to the argument equal to the power, right? Remember
Yes,
that?
sir.
And if you convert it to the index form, it's the base to the what? Base to the
Base to the power equals the argument.
right. So once you put it in the index form, it shouldn't be too hard to solve it. You might just have to get rid of the square. I mean, you could do that, or you could expand and solve the quadratic. There's two ways you could do it. So Shay, when you write it in the index form, do you know where to go from there? Or is that the part that's confusing you?
I got the x equals to something squared.
So you got x plus 1 squared is equal to what?
I put 7 squared over 49.
Okay. Yeah. So you have x plus 1 squared is equal to 49. That's what you have so far.
Yes, sir.
There's two things you could do. You could expand the brackets, make it a quadratic, and factorize. That's one thing. Another thing you could do is, if you are trying to find for x, and right now you have x plus 1 squared, what can you do to undo the square? Think shape. What can you do to undo the square? What's the opposite of squaring something?
Square rooting it.
Yeah.
Oh,
If you square root both sides, wouldn't the square root cancel off with the squared on the left-hand side?
yes, sir.
Yeah. And on the right-hand side, you'll end up with the what? What? So you had 49 on the right-hand side. So if you find the square root of that, what will happen?
You're just into 7 squared.
No, it's into, well, it was just in the 7. Square root of 49 and
Oh,
7.
wait.
Yeah.
Yeah, when you cancel it out.
Mm-hmm. Isaiah, I didn't check what you're saying just yet, right? But I think it's the exact same thing I'm telling you over here. Isaiah, did you hear what I was telling you about square
Yeah.
rooting?
Mm.
I'm guessing that's what you do.
Yeah.
The square root is as well, yeah. Square rooting is the best bet over there. So Shay, if you find the square root of x plus 1 squared, you'll just end up with x plus 1. And if you find the square root of 49, that'll just be what? What will that be?
Wait, can you repeat? Sorry.
On your right-hand side, right? If you do find square root, you'll get what? What's the square root of 49?
7.
Right. So what should you have in the next line then?
The
After
x
after
plus 1.
square root, x plus 1 is equal to,
7.
can you solve that?
Yes.
Yeah. And would you get the answer?
X equals to 6.
Right. How was that?
It wasn't difficult. Just threw me off a little bit.
I could imagine. Yeah, x plus 1 on thing, and it's squared. Now, if you knew logs like extremely well, you could figure out the answer immediately. So and we understand that it's always log, base, and power equal arguments. Now I say
Yes, sir.
it's always log the base, right? Arguments.
And then power.
Great. So in other words, wouldn't I have to raise the base to the power to get the argument? Isn't it always base to the power, and that would give you the argument in the index form?
Yes, sir.
So in other words, if x plus 1 is the base, forget about the x plus 1 for now. But tell me, what squared is 49? What squared is 49?
7 squared.
Yeah, so if you know that this has to be 7, then you could just say x plus 1 is equal to 7 and x will be equal to 6. Think about it. Wouldn't this have to be 7? Because if this is the base, right? And the only base squared that is 49 is 7.
Oh, yes, sir.
Yeah, let us soak in for a bit. 7 squared is the only 7 is the only base that when squared will give you 49. So that would have meant that the base, the whole thing would have had to be 7. And if the whole thing is 7, then x would have had to be 6 because 6 plus 1 is 7. Everything making sense now?
Yes, sir.
You sure?
Yes, sir.
Cool. But let me just run through it one more time. Shayna, I didn't hear anything from you.
Yeah, so
And
so I got the
Serena.
answer. But
And
I'll follow.
you didn't submit.
Oh, sorry.
Submit one time, right? And
Sure.
Serena, did you get through? Or you having some trouble with this? One thing though, Serena, um, actually that's fine. That's fine. You're allowed to do that. You're allowed to do that. Right? I just like you see that where you cancel off the two? That's kind of an illegal move. You can't really do that. So I would advise not to cross off the two like that. Just leave it. Just come down, but don't cross off the two. I'll show you the better way to write that. I'll show you the better way to write that. Don't worry. So everybody should know that in the log form, it's always log to the base to the argument equals to the power. And if it's in the index form, it will be base to the power equal to the argument. Serena, I'd like you to unmute.
Yes, sir.
Yes, Serena. Let me know if you hear me.
Yes, sir.
Yeah, okay, cool. Wait, let me just check Shayna's working fast. All right, cool. Yeah, so Serena, before we do the question, right, let me just share how easy this question was. So Serena, in the log form, it's a log base to the argument, and that would give you the power. So in other words, Serena,
Yeah.
if the base is x plus 1 and the power is 2, I must ask you, what would I have to square to get 49? What squared is 49?
7.
So that would have meant that x plus 1 has to be what?
7.
Yeah, and x would have be 6.
Oh, okay.
Yeah. Now we understand now, right? Because in the log form, it's base to the argument to the power. And in other words, what base to the power 2 would be 49. Obviously, that base would be 7. So x plus 1 is equal to 7. Yeah. Poof. I know it's a little mind blowing. Yeah. Right? But let me show you the formal way to do it. So the base here is x plus 1, right? We're going to square that entire thing. And that would be equal to the argument, which is 49. Right? Next thing we're going to do is we're going to find the square root. We're going to find the square roots on both sides. Serena, why do you think I'm finding the square root?
To get just x plus 1.
Correct. Because the square root gets rid of the squared. They are inverse functions. Now, anytime you find the square root of something, you're going to get a positive and a negative solution. More on this later. But so far, Serena, are you good?
Yes, sir.
Like I said, square and square root, that would cancel off. So we end up with x plus 1 over here. And that would be equal to plus or minus what? What is the square root of 49?
7.
Great. So we're going to have two solutions, but you'll see what's going to happen. So the first solution is going to be positive case. So imagine you have x plus 1, and that's equal to positive 7, right? If you move across the plus 1, you'll end up with 7 minus 1, which is equal to what?
6.
Right. That solution is valid because you could have log of 6 plus 1, which is 7, right? Remember, Serena, at the start, didn't we say that the base has to be, it has to be 7 to get it to work out?
Yes.
Okay, cool. Right. Now let's continue. So Serena, if we are considering a negative case, x plus 1 will be equal to what?
-7.
Right. But let's check out if that would make any sense, right? First of all, I want to define log base of a negative number and see what happens. So log, let me just try negative, log base -2, 4. Press equal and bam. We can see a math error. So, Shay, do you think you could find log base of a negative number? Do you think the base could be negative? Look at what happened, Shay. If I said that the base is, if I say the
It'll
base,
be a math error.
yeah, it'll be a math error. Yeah, you can't find log base of a negative number, right? But if you did work it out, you'd end up with x is equal to -7, -1, which is -8. And like I said, this would not work out, right? You could try it. So you could try to plug this back in, you'll see math error. Let's check if that's gonna happen. So Serena,
Yes,
if
sir.
x is -8, right? I would put log base -8 plus 1, then I would put 49. Now, if this is feasible and it makes sense, I should get what as my answer?
2.
I should get 2. Instead, I get math error. You know what I mean? I mean, this solution is invalid. If I use 6 instead of -8, it would work. Because again, 6 plus 1 is 7, and 7 squared is 49, which makes sense. Right? Cool. Let me just write down the reason here. So this would be invalid. Right? Right. Now, let me just say one thing up on the merit list, right? Do you have plans of being on the merit list?
What? Regardless?
The merit list, like, do you know what the merit list is?
Not really.
Oh, the merit list just refers to the top performers in the whole Caribbean.
Oh.
Yeah.
Mm,
So if you want to be a top performer in the Caribbean, you should probably have this extra part over here with the plus or minus and show that this will be invalid because they can't find the base of a logarithm if it's negative. So this is the stuff you should have if you want to, be on the merit list. It's not necessary. You'll get the question correct. Okay. You see, if you didn't put this, you would still get full marks, right? If it truth be told, you really just needed to have what I have on the screen there. But if you have this, this will look a lot nicer and it will show that you have a further understanding. And yeah, it will make it look like you have more aura. But sure, you understand everything I did so far? Like,
yes, sir.
cool. So again, some questions require you to go from the log form to the index form. Shayna, are you confused by anything that I did?
No, sir.
Now, Shayna, you see, you left out the plus or minus part. Now, while you will get the question correct, if you want to end up on the merit list and you want to flex a bit, you should probably put plus or minus, because anytime you find the square root of a number, you get a plus or minus solution.
All right, so
Yeah, and as a matter of fact, I would actually prefer if you will put in the plus or minus part, because I see potential. I don't want it to just be normal. I want it to be exceptional. So put the plus or minus part. Shay, do you know why when you find square root of something, it's plus or minus? Do you know why?
So repeat the question, sorry.
Do you know why when you find plus or wait, I'm asking you, do you know why when you find the square root, you get a positive and a negative solution? Do you know why? Do you know why we
Not
get two solutions?
not really, sir.
Okay. And when you find the square root, you're asking yourself, what two numbers could I multiply by to get back the original number?
Yes, sir.
So like, watch this. 7 by 7. What's 7 by 7?
49.
So wouldn't that be a solution for the square root of 49?
Yes, sir.
How about negative 7 by negative 7?
49 also.
Right. So isn't that also a solution for this?
Yes, sir.
Yeah. So that's why. Because square root means you're multiplying some number by itself. And a positive by a positive could give you a positive number. And a negative by a negative could also give you a positive number.
Yes, sir.
That's why it's plus or minus. Right? So add in the extra bits, and that'll be it for class today. I will send you all some homework shortly. Yeah. Because I don't want everybody to be completely lost when we start back. I want to make sure they do some work. So when we start back, when school reopens, I'll still have some memory of what we did. Serena, you okay?
Yes, sir.
Okay, great. Sheena,
okay.
nice. Yeah. Sheena and Serena, did you all include the part about the plus or minus?
Yes, sir.
Great. So yeah, that's it for class today. See you guys tomorrow, well, some of you, for physics. Bye, everybody. Hope you have a blessed
Thank you.
evening.